Hello 8th graders, this video is all about ELR 7.2, which is calculating velocities and accelerations using gravity. In the last lessons we've been talking about how weight and mass are two different things, and gravity is an acceleration that causes anything that has mass to apply a force. And so if we rearrange Newton's second law, we get this equation, which is exactly the same equation with just some different words swapped out. In this lesson, we're going to talk about how do we actually calculate using gravity. So in a previous lesson, we've gone over this equation, the equation for acceleration, and the only thing that we're adding to this equation today is we know the acceleration of gravity on this planet. So on this planet, the acceleration of gravity is actually 9.8 something, but that is so close to 10, and for the purposes of 8th grade science, we're just going to round it to 10. Just know that it's not the true number, it's just the one that's rounded to make things a little bit easier for us. So we can really think about the acceleration equation when we're talking about gravity like this. The acceleration of gravity is 10, but it's still the same equation. That equals change in velocity over change in time. We can also use the little triangle to our advantage. It's just every time the acceleration part is going to be 10. So let's use an example. We're going to take Justin Bieber and push him off a cliff. So let's say we've taken Justin Bieber, we've shoved him off a cliff, and we want to figure out his acceleration, his velocity, and how far he's fallen at each second along the way before he meets his untimely demise down at the bottom. We're going to be using our equation that we've just saw on the other slide, and we're also going to use this little triangle. If you are in an honors class, I want you to know that the distance that something has been falling can be calculated using 1/2 times gravity times time squared. If you are not in an honors class, you can ignore this. So let's consider what happens to him right at time 0. This is the moment he's been pushed off, but he hasn't started to move just yet. He's just kind of just been pushed over the edge. The acceleration of gravity on this planet is 10 meters per second per second. It's never going to change, at least not on this planet. So his velocity, because he's just been shoved off, is 0. And if you've plugged everything into the distance equation, he hasn't gone anywhere yet. So 0 meters per second, or 0 meters is what it should say, so far. Now let's consider what's going to have happened after 1 whole second. The acceleration of gravity says that it's going to add 10 to his velocity every second. So acceleration doesn't change. He's still going to be accelerating at the same amount. Gravity is still the same 1 second later. But now he's been falling for a second. So we've added 10 to his previous 0, and so now he's going 10 meters per second. If you do the math using this equation, he's now fallen 5 meters. I want you to pause the video and think about what should happen in box 2 and 3 and start it again when you're ready to go. If you're still watching, you're ready to check. 2 seconds later, gravity hasn't changed. It's still going to be pulling him down at 10 meters per second per second. However, his velocity, he's now going faster. Acceleration adds 10 every second. So before, in the last second, he was at 10, so we're adding 10 more. Now he's going 20 meters per second. And if you plug this into the distance equation, now he has fallen 20 meters. Take a look at what's happened to the distance so far. He went from 0 to 5, and then 5, a big jump to 20. Think about why his distance is going up so fast. It's because his velocity is getting greater and greater. He's covering more ground per second the longer he falls. In the 3rd second, gravity has not changed. It is still 10 meters per second per second. But now we've tacked on 10 more to his velocity, and now his distance has really jumped up. He's now traveled 45 meters. Off to the side, you've got these same boxes that I have on my screen. I need you to pause the video and answer the questions on your notes. On the next page of your notes, there are some blanks that we're going to fill in, but it's important to recap what we've already done. So if velocity and acceleration are going the same direction, we give them the same sign. So in the last lessons, we've talked about how acceleration has a direction. Well, gravity always points in the same direction. So consider the Justin Bieber situation. In that situation, acceleration and velocity were going in the same direction. Since gravity points down and Justin Bieber was moving down, acceleration was adding to our velocity because they're going together. Well, think about this. What if you throw something up into the air? Well, if you look at the picture, there are kind of like 2 halves to this picture, the part where it goes up and the part where it comes back down. Let's think about what the signs are going to be like in this kind of a situation. Well, when the person first throws the ball, its velocity is going to be going up. But because acceleration always points down, acceleration is going to be reducing that velocity. It'll start off fast when it leaves their hands, but gravity is going to make it slow down and slow down and slow down. It's going to be reducing it or making it take away. Then once it starts coming back down, just like when Justin Bieber was pushed off the cliff, now they're going to be going together. So they're both going to be in the negative direction. Acceleration is going to make velocity move faster and faster. Let's think about an example of this. Suppose I put a puppy into a cannon and I fire the cannon straight up into the air. Don't worry, the puppy is built for this. It's a cannon puppy. Well, all that we're being told is that the puppy is leaving the cannon at 40 meters per second. Just with that information alone, we can figure out how fast this puppy is going all the way along the way. Here's how. In the little first box, we're going to assume this is 1 second later. If the puppy leaves the cannon going up into the air, but gravity is going to be pulling down against the puppy, gravity is going to be reducing the puppy's velocity by 10 every single second. So 1 second later, the puppy is now going 30 meters per second. Because we've kind of defined the up direction as positive, that means the acceleration of gravity is negative 10 meters per second, but it's always 10. 2 seconds later, gravity has had another whole second to reduce the puppy's velocity, and we're now down to 20 meters per second, but gravity has not changed. Gravity isn't going to change depending on how fast you're going. Gravity is the same all the time. I need for you to please pause this video, and you're going to fill in the remainder of the boxes. Please notice that second number 4 has been plucked out of there. It jumps from second number 3 to 5, and you'll see why in just a second. But fill in all the boxes that you can. If you're still watching, you're ready to check. 3 seconds later, the puppy's velocity has been reduced by another 10. So we've gone from 40 to 30 to 20. We're now down to 10. Once it's come around the top of the curve, at the very tippy top, that was 4 seconds later, and 4 seconds in, we've reduced 10 each second. So at the tippy top, the velocity was 0. Now the puppy's going to start coming down the other side. Now velocity and acceleration are in the same direction. So our velocity should be an increasing number. So now it's gone from 0 at the tippy top down to negative 10. But acceleration is still taking away 10 each time. 1 more second later, we're at negative 20. 1 more second later, negative 30. And once it gets all the way back down to the bottom, negative 40. Check this out. When the puppy left the cannon, he was moving at 40 meters per second. And when he came back down, he was moving negative 40 meters per second. If you throw anything up into the air and you ignore air resistance, everything comes back down at the same velocity that it left your hand, just in the opposite direction. So if you've ever heard the advice, don't fire guns up into the air, this is why. Bullets will come back down at the same velocity that they left your gun, except you don't know where they're going to land. It's super dangerous. Off to the side of your paper, there are these same 2 questions that are on my screen. I've kind of already answered the first one for you, but I want you to explain why, and then the second one is also on your screen. Start the video again when you're ready to check. If you're still watching, you're ready to check. The puppy is going 0 meters per second all the way at the tippy top, and that's because he's halfway through his journey, and so he's lost all of his velocity, and he's ready to start turning around and coming back down and getting it all back. Second one, how long will it take the puppy to reach negative 500 if he continues to fall? Well, we're basically doing negative 10 every single second. If he's at negative 40 right now, that means he needs to fall or reduce his velocity by another 460. That's another 46 seconds in order to get to that velocity. The last thing I need you to do for this lesson are the 4 practice questions on your paper. When you are ready to check your answers, please start the video again so that you can see how you did. If you're still watching, you're ready to check your answers. So the ball thrown straight up into the air, leave your hand at a velocity of 20. It's going to take 2 seconds to get to the top because velocity is going to be reduced by 10 every single second it goes up into the air. If somebody catches it at the top and chucks it down at you at 8 meters per second, that means that it's coming down now with the help of gravity, but it had a starting velocity of 8. Well, acceleration of gravity is going to add 10 to that every single second. So it's going to come down at a velocity of 28 meters per second. 10 for each second, that's what gravity put on there, and then the original 8 that the person at the top gave it. For the trampoline question, so Steve is falling towards this trampoline, and he's at rest to begin with. He doesn't have any velocity. If he's traveling at 20 meters per second when he hits the trampoline, we're supposed to figure out how long that took. Well, gravity adds 10 to you every single second. So if he ends up at 120, that was 10 plus 10 plus 10 plus 10, all the way up to 120. It took him 12 seconds to get up to that velocity. At 15 seconds, this is basically 3 seconds later, we're assuming that he hit the trampoline and shot right back up. Well, when he starts going back up, gravity is now going to be reducing his velocity. So he was going 120 when he hit the trampoline. Now he's going back up, and he's going against gravity. So he was going 120. We're going to take away 10 for 3 seconds. That means that he was going 120 when he hit it. 3 seconds later, we reduced by 10 each second. That's 90 meters per second.